Okay, good afternoon. This is S. Gold, back with another open source demo video. Today is August 27th, 2022, and I'm going to be demonstrating VhacdTuner, which is an application that's part of the Minier project. VhacdTuner is a tool for uh, tuning the VHACD algorithm, which does approximate convex decomposition of a mesh. So we're decomposing a mesh into convex hulls, which is an important operation for efficient physics simulation. So I'm going to run the application. It consists of uh, 4 screens. It's written in JMonkey engine. The first screen, so the first step, is to locate the model that we're going to decompose. I have a particular model in mind, so I'll just quickly navigate through the file system to that model. It's called Unch. It's in the GLB format, which is the binary version of GLTF. This application also will input text GLTF. It will also input J3O files. So many different input formats you can use depending on your workflow. So now I've selected the file. Here's the file name. Click Next. It takes me to the second screen where we load the model. In some cases, you might want to fiddle with the split of the path into root and asset path, but usually the application guesses correctly. It understands that /models is the start of the asset path and splits the path accordingly. If that's not correct, you can adjust the split using these plus keys buttons. So we load and preview, show the axes. You can adjust the view, rotating it using the A and D keys, zooming in and out with the W and S keys, translating up and down with the Q and Z keys, and turning the camera with dragging the left mouse button. The third screen is where most of the work happens. Here we're looking at 2 different sets of parameters, one for the classic version of the algorithm and one for version 4, which just came out this summer. And the 2 versions have almost completely different parameters. The only parameters they have in common is voxel resolution, which defaults to 100,000 for each of them, and maximum vertices per hole, which defaults to 32 for each of them. All the other parameters are specific to a particular version. And since we have 2 different sets of parameters, we can compare them side by side and decide, which set of parameters we actually want to use. So now I have 2 results. I have a classic result, which has 6 hulls, and I have a version 4 result, which has 64 hulls. And the version 4 result is a lot more true to the original mesh. It's got the smooth inside loop, whereas the classic version produces a sort of diamond-shaped or kite-shaped loop. It's also got the correct taper on the arms, which the classic doesn't capture. But the classic is also producing a much simpler mesh. So in order to actually properly compare these algorithms, you need to tune them each to be a good match for the model that's being decomposed. And it's not going to allow me to make any other changes because I haven't told it which of these 2 I prefer. So ranking results is very subjective. You click on the prefer button to tell the tuner which output you prefer. I'm going to say I prefer the accurate v4 version. But I would like to make a simpler version that's still accurate, but not so many holes, not so many vertices. Anyway, once you've got all the results ranked, then you can go to the 4th screen, which shows all the ranked results and allows you to save them. There are 2 ways to save results. One is in J3O format, which produces a copy of the original model with a rigid body control added to it. And it stores that output in the written assets folder under the current working directory. in a file with a timestamp on it, so you can save multiple results and not worry about trashing previous results. So it's currently 3:35 local time, and it's got 1535 as the first 4 digits of the timestamp. You can also save it as a Java file, in which case it will just have the parameters you would need to recreate the result. So I've done both of those. I'm going to go back and do a little bit more tuning. I'd like to try the version 4 algorithm with a smaller number of convex holes, like maybe 20. So I run that, got a new result, and it's not quite perfect. It's got the asymmetry between the left and right arms of the, and there's a little bit of sharp edges notable on the inside of the loop, and even on the outside of the loop too. But it's clearly better than the one it wants me to compare it with. So I'm going to prefer this one. And I think I actually do prefer the one on the right here. So now if we look at the ranked results, there's 3 results. And it shows very clearly what the differences are. And then we can, if you want to look at the results, like if I want to compare the classic and the V4 again, I can select which one I want to appear on each side and go back to the third screen. And here I can see exactly what the 2 results look like. So yeah, I can go and create a classic version with a higher resolution. That's a good way to tune the classic algorithm and go from 100,000 voxels to 1,000,000 voxels and see if that produces a better result. It's definitely going to take longer. 1,000,000 voxels takes a while, but it might produce a better result. Okay, yeah, so now it's asking me to do a comparison. I really think I prefer this one with this one. Now I've got 4 ranked results. The one on the right, this is the one that was on the right, this is the one that's on the left. The one that's on the left is definitely my favorite. So maybe I stop there. Anyway, this is how the tool is meant to be used. If you have questions about it, you can email me or find me on the JMonkey Engine Hub. This is Escold signing off for August.